So this is just a little introduction to chapter 13. We are now in part, what is it, 4 of the text, which is nonlinear systems. So this chapter is on nonlinear systems and linearization. Thus far, we've mostly considered linear system models. Many of the analytic tools we've developed, ODE solution techniques, superposition, eigendecomposition, stability analysis, impedance modeling, transfer functions, frequency response functions, do not apply to linear systems. In fact, analytic solutions are unknown for most nonlinear system ODEs, and even basic questions are relatively hard to answer. For instance, is the system stable? So everything's different. A little caveat on that, one thing that you might think is out of date would be the suspiciously named linear graphs, which we used as a modeling technique for linear systems. But turns out that linear graphs are okay for nonlinear systems. So I know it's surprising, but linear systems can use linear graphs, and so can nonlinear systems. The linear in linear graphs is actually there to mean line, which has nothing to do with the linearity of the system. It's a little bit of a strange name, but that's what we're stuck with. So anyways, linear graphs are okay for nonlinear systems. So in the following chapters, so 13, 14, 15, we consider a few analytic and numerical techniques for dealing with nonlinear systems. So we can learn quite a bit about nonlinear systems, and we can do analysis of them, but unfortunately, many of our techniques that we've learned thus far only apply to linear systems. A lot of the intuition that we've gained on how systems work will continue to apply, but some of it will not work anymore. We have this concept of superposition, for instance, that is no longer going to work for linear systems. So if you double the input in a nonlinear system, you don't necessarily double the output. Another thing that happens is if you put in a sinusoid, you might not get out a sinusoid. So nonlinear systems are a little bit strange, and a lot of really interesting behavior comes out of them. And a lot of this behavior is actually, you might think it's all negative, like that nonlinearities are going to always hurt us in our system performance. But in fact, a lot of times we take advantage of nonlinearities in systems. So nonlinear systems do frequently arise, and we need to be able to deal with them in some way. So I'm going to give us some of the basics for how to deal with nonlinear systems in the following chapters. And of course, there's a whole lot more to it. So if you're interested in nonlinear systems, there's a lot there. So this will hopefully give you a start to your studies of nonlinear systems.